In this video, we're going to cover units of measurement, what they are, the SI system. We're going to compare it with the imperial system, and we're going to talk about base units and derived units. Question: which of the following is the longest? A. 100 centimeters, B. 1 meter, C. 39.37 inches, or D. 3.2808 feet? The correct answer is they're all the same. The distance is exactly the same in all four answers. The only difference between them is the units of measurement. So 100 centimeters is the unit. In B, the unit is meters, C, inches, and D, feet. So we have four different units, all of which measure distance. So the first thing to understand is anything that you can measure or anything that you can count will have a unit attached to it. So if I ask you how much money you have in your pocket and you tell me 26, that doesn't mean anything until you tell me the unit. It could be 26 pence, 26 pounds, 26 dollars, or euros, etc. So all of these are examples of units of currency, but anything that can be measured will have its own unit. So as you can imagine, in plumbing, measuring is very important. You're going to have to learn to measure many different things. You've got the length of pipe diameter, water temperature, water pressure, water flow rate, and loads of other things. So all of these things have their own specific units, which you're going to have to learn. Question: which of the following is not an SI unit? A. Meter, B. Kilogram, C. Gallon, or D. Second? The correct answer is gallon. Why? Because meter, kilogram, and second are all SI units, whereas gallon, although it is a unit of measurement, it doesn't belong to the SI system. It is an imperial unit. So let's cover the difference briefly between the imperial system and the SI system. So first thing, SI stands for Système International. That's from the French, because this system originated in France. However, today, it's considered the modern system. We also refer to it as the metric system, and it's used all around the world. So the SI is modern and worldwide, whereas the imperial system predates the SI system. It's much older. It originated in the UK, from where the US adopted it. And even to this day, in regular day-to-day speech, very often people still use the imperial system in the US and also in the UK. So examples of this are inches and feet. If you're talking about somebody's height and you say they're 5'4" or 6'2", that means 6 feet 2 inches, right? Then we have yards, miles. If you're driving in a 30-mile-per-hour zone, that still gets used. Then we have pounds and ounces for weight and gallons for a volume of liquid. Okay, so each of these have their own equivalent in the SI system, which you'll probably be familiar with. So generally today, when we measure things with a measuring tape, we talk about meters. If you weigh yourself on the scales, it's going to be in kilograms. We measure time in seconds, minutes, hours, etc. So these are just examples of the two different systems, units from each of the two different systems. Okay, so because the imperial system is older, it very often is based on different standards. So body parts, feet. When we talk about feet, that would have come from some kind of measure of what people's feet were, right? So you can imagine that's not the best way to measure things because we don't all have the same size feet. So the way around that, or the way that the SI system improves on that, is that the system is logical and it's decimal based. So decimal means based on the number 10. So I'll explain that now. So for example, 1,000 millimeters, if you divide that by 10, you've got 100 centimeters. And if you divide that by 100, which is a number based on 10, you get 1 meter. So this makes converting up and down much easier, whereas in the old system it wasn't like that. So for example, 12 inches equaled 1 foot. So if you wanted to divide 1 foot into inches, you'd have to know how to divide by 12. Which is much more difficult than dividing something by 10, where you just remove one of the zeros. So similarly with feet and yards, 1 yard equals 3 feet. So you can see all in all this SI system, it's more logical, it's easier to work with, especially in today's day and age where we have a lot of international trade and people just travel. So if you travel abroad, you knowing the metric system and then using it there makes it much easier for you. Or if you have a company that is working on a project with a company from another country, it makes it much easier working from the same SI system. Okay, so just remember, SI stands for System International. Moving on. Okay, why do we need to know Imperial then if everybody uses SI these days? Okay, because, as I mentioned before, in day-to-day speech, let's say you're working with an older colleague or somebody who's teaching you, or even just customers, very often people still refer to things using the Imperial system. So here are some examples. If somebody asks you to fit them a 1/2-inch pipe, right, you need to know that that's the equivalent of a 15 mil pipe, according to the SI system, the metric system, okay? Similarly, a 3/4-inch pipe is at 22 mil. When we fit radiators, very often we still talk about them in terms of feet. So a 4-foot radiator, 6-foot radiator. So they've got their metric conversions with water tanks storing water. People talk about gallons. So you're going to have to know how to convert, or at least be aware that there is a way to convert these old Imperial units into the modern SI equivalents. Okay, question, which of these is an SI base unit? Okay, so we've talked about SI, but now I'm asking you, which one of these is a base unit? A, Newton, B, Joule, C, meter, or D, Pascal? The answer is C, meter. Why? Because although all 4 of them do belong to the SI system, they are all units in the SI system, A, B, and D are not base units. They are what is known as derived units. So within the SI system, you can break all units down into 2 groups. We've got base units and derived units. Okay, so when you think about base, think basic. A base unit is a basic unit. It's a building block. It's not made up of different things. It just is what it is on its own. Whereas a derived unit, you derive it, you get to it by combining 2 or more other units. Okay, so if that's confusing, let's do a few examples. So for measuring length, we just talk about meters, right? Mass, we talk about kilograms. So be careful with this, because in day-to-day speech, if I ask you how much do you weigh, you'll tell me 60, 70, 80, 90 kilograms. So usually we think of kilograms as measuring weight. However, in the SI system, scientifically speaking, kilograms measure mass. So that's just something to be aware of. Time is measured in seconds. So these things, they're just standalone units by themselves. Whereas with derived units, we need to take 2 units and combine them somehow, usually through multiplying or dividing to get to the derived unit. So if I want to measure the area of a bathroom, let's say I'm going to buy some tiles because I want to redo the walls or the floor of the bathroom. The first thing I need to know is how many tiles do I need? How many square meters do I need? Because square meters, meters squared, is how we measure area. So how do you derive meters square? You take the length of the room, the length of the floor, and you multiply it by the width of it. So we've got meters and meters. These are two base units, but we're combining them in this case through multiplication to derive square meters. And square meter is the unit, is the SI unit for measuring area, right? So that's a derived unit. Same thing with volume, right? Let's say you're installing a water tank, and you need to calculate what the required volume is, right? So you're going to have to look at the length, the width, and the depth. So in this case, we've got three base units, meters, 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 and we times them by each other to derive cubic meters, which is a derived unit in the SI system. Okay, so there's loads of derived units. I'm not going to go through all of them. These are just a couple. So Newton, if you're measuring force of something, that's measured in newtons. But to derive, to find out how many newtons force there is, you're going to need to know the kilograms, and then you're going to have to multiply it by meters divided by seconds squared, right? So if you didn't notice just the red bits, these are what's called mathematical operators. So just remember a basic unit. A base unit is basic. There's no maths involved in it. Whereas a derived unit, you're combining two or more other units, usually by timesing one by the other, or dividing, or a combination of both. Okay, so that's base and derived. So, question, which one of these is an SI derived unit? A, kilograms. B, seconds. C, amperes. Or D, newtons. So the correct answer, if you were paying attention, you'd know that it's newtons. Why? Because kilograms and seconds and amps, they're all base units. A kilogram is just a kilogram. You don't have to times, multiply, add up, divide any other units to get to A, B, or C, whereas in Newton, to calculate the Newton, there's a specific formula to it. You have to take other base units and combine them to derive the answer of how many newtons. So the answer for this, D, Newton is the derived unit. And this is the formula for a Newton. So Newton is 1 kilogram times 1 meter divided by seconds squared. Right, so you'll see you've got kilograms in there, which is a base unit, meters, another base unit, and seconds, base unit. And you're multiplying and dividing them to derive how many newtons. Therefore, the Newton is a derived unit, whereas these are base units. Okay, a few other examples. You've got energy which is measured in joules, and to calculate joules, you need to know the newtons and multiply it by the distance in meters, right? Electrical power is measured in watts, that's joules divided by seconds, and we've covered these already. Okay, so the takeaway from here is a derived unit is when you combine other units with some kind of maths like multiplying or dividing to derive joule, that's to derive the actual derived units. So in this case, it's joules for energy or watts for power. Okay, recap. SI stands for System International. It's the modern worldwide system for measuring things. Within the SI system, all units can be broken down into either basic units, which are standalone by themselves. They're not composed of any other things. And then you've got derived units, which are combinations of other units. They can be either a combination of 2 base units, 3 base units, 1 base unit, and another derived unit. There's loads of different combinations. The only thing you need to know is that a derived unit is a combo of other units, okay? And it's made usually by multiplying or dividing.